Are you ready?
Yes, sir.
Okay. So I'm sharing my screen here. Is it visible to all?
Yes, sir.
Yes, sir.
Yes.
Okay. 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 So these problems we had covered in last lecture, right? Am I audible to all?
Yes, sir.
Yes, sir.
See, this is the next problem. Okay. This is next problem. The value of double integral, integration 0 to pi, 0 to x sine y upon pi minus y dy dx is, right? Can anyone tell me how to solve this problem?
So we need to change the order of integration
Yes,
first.
Put
yes.
f of a minus x is equal to f of
Yeah. So that means in such problems, we change the order of integration and then we can easily solve those problems, right?
Yes.
Agree with me?
Yes, sir.
Okay. So many problems we have already discussed of this type. Okay. Right. So I will leave this problem for you. Will you solve this problem after completing this lecture?
Yes, sir.
Okay. Okay. So let us move further. Okay. So this is the next problem. This is next problem. Just a minute. I'm just stop sharing here because all of you are not visible for me right now. Okay. Let me do it again. Is it visible now?
yes, sir.
Yes.
Yes.
Yes, sir.
Okay. See the area of part of a surface of a paraboloid. One paraboloid we have, right? X square plus y square plus z is equal to 8. Lying inside a cylinder. We have one cylinder x square plus y square is equal to 4, right? And we have to find the area of paraboloid. So do you know the formula? Anyone knows the formula? How can we find the area of any surface in R3? Do you know the formula?
Yes, sir. S is equal to 2 pi y integration a to b
Huh?
root over 1 plus dy dx whole square into dx.
Yeah. So surface area is double integration over T square root of multiple ways we have to solve the same problem. Getting?
Yes, sir.
Using parameterization also we can solve this one. But whatever I'm telling now, that is also one of the standard formulas. So 1 plus
That is-
delta f by delta x. You are telling the same formula, na?
Yes, sir.
Plus delta f by delta y square dx dy. So when you have any surface in R3, so this time we have a paraboloid, right? This time we have a paraboloid. So paraboloid we have, let me draw. So I don't know how does it look, need to check. Yes, so it will be like this kind of paraboloid we have, right? It doesn't matter, huh? How does it look? See, so one function, one surface we have. So what is its equation? X square plus y square plus z is equal to 8. So this is the paraboloid we have and we have to find its surface area. इसका surface area find out करना है मगर which lies in this cylinder. Getting? We have at a base we have some cylinder. At base we have a cylinder. So having a it's just like a base is circle, you know. This kind of cylinder we have, right?
Yes.
Okay. So equation says this is a circle in xy plane with center 0, 0, radius 2. That means if you see in xy plane, so it will be like this. This is a circle in xy plane. Center 0, 0, radius 2, right? Okay. So we have to find surface area of that paraboloid. That means this is the main equation we have. So with the help of it, I will find z. My z is equal to 8 minus x square minus y square. So whatever the z we have, that is nothing but f of xy. हाँ, यही हमारा f of xy है. The f we want here ना, this is our f. Z is equal to f of xy, right? So as you can see in this formula, we want del by del x and del by del y. Both things we want. So let us find the partial derivatives. Can anyone tell me the partial derivatives?
8
Del by
minus 2x.
It is
Sorry, minus 2x
minus 2x and del by del y. It is
minus 2y.
minus 2y.
minus 2y. Now the next task is to put these values in this formula. So surface area, I will write in short, surface area, double integration over t, right?
Yes, sir.
Square root 1 plus divided by x square. It means the square of this minus 2x, which is
4x.
4x square. Okay. And similarly, next one will be 4y square dx dy. Now simply we have to solve this integration. But we are facing problem because we don't know the limits. If you have the limits, you can easily solve, right? So what I mentioned, t. T means what? Projection of this surface. This kind of surface we have, you can see on the screen, this kind of surface we have inside the cylinder. But see, if you take its projection in XY plane, you will get the same circle. You will get a same circle in XY plane with center 0, 0 and radius 2. All of you are agree with me?
Yes, sir.
Now,
Okay.
can you explain it once more? What do you mean by projection?
Projection, that means simply you can take its shadow in XY plane. You
Yes,
haven't
sir.
studied projection, shadow, kind of shadow. Getting na?
Yes, sir.
Okay. So that means if you take its projection in XY plane, you will get circle. So that means we have to solve this double integration over this circle. But do you know when we have a circle, normally we go for polar coordinates, right? We solve the problem with the help of polar coordinates. Do you remember the substitution? How to convert this problem in polar form?
X
Yes, sir.
equal to r cos
theta, y equal to r
and
cos
y
theta.
equal to r sin theta.
X is equal to r cos theta, y is equal to r sin theta, and dx dy,
R dr d theta.
R dr d theta.
r dr d theta, right? And you remember in a polar form, we draw strip which starts at origin.
Yes, sir.
It is just like a minute hand of a clock, getting? So it rotates, and in this direction, it rotates in this direction, and it covers the complete circle. Agree with me? So now we want the limits of r and theta, right? So what will be the limits of r? The strip is bounded below by 0, right?
Mm.
And strip is bounded above by a circle whose radius is 2. So that's why its equation is r is equal to 2. So r varies from 0 to 2. And what will be the limit of theta? Tell me.
0 to 2 pi.
Yeah, we have to cover a complete circle. So that's why we should rotate it by 360 degree. That means 0 to 2 pi. So let me write the area is equal to, now we have the limits. In polar, we always write a limit of r first and then limits of theta, 0 to 2 pi. Okay, so let us put it here. Yeah, 1 plus 4. X square means what is value of x? R cos theta. So r square cos square theta. Agree? Y
Yes.
square means 4 r square sin square theta. And dx dy means r dr d theta. Will you guess the next step?
Yes, sir. We
Yes, sir.
take
4r
common 4r
we
square.
Yeah, we can take 4r square common. If you take 4r square common, you will have cos square theta plus sin square theta, which is 1.
1.
Okay, so that means we have this kind of integration. Tell me how to solve this integration.
So we can substitute 4r square equal to t.
Very good. Putting 1 plus r square, 4r square is equal to t. So the next task is to find derivative. What will be its derivative? 8 r dr, right? Is
Yes.
equal to 8.
Yes.
R dr, we have this term already. So let me write RDR is equal to dt by 8. What is the next task?
Limit.
Limits.
The original values limits of R 0 to 2. So if I put R is equal to 0 in this equation, what will be the value of t?
1.
And if I put 2,
17.
agree. I is equal to 0 to pi, 1 to 17. Root, we have called it as t. RDR means dt by 8 d theta, right? Inner integration with respect to t. 1 by 8 constant. Outside 0 to 2 pi. What is the integration of root t?
E to the power 3 by
3
2
by
by
2 upon
3 by
3
2.
by 2.
Power 3 by 2.
Exactly. T raised to 3 by 2 divided by 3 by 2, 1 to 17, right? So 3 by 2 is a constant again. We can take it outside. So 2 to cancel. So 8 into 3 by 2. Okay, I will cancel it in next step. 0 to 2 pi. Let us put the upper limit, lower limit. Tell me what will you get? 17 raised to 3 by 2.
Minus 1.
1 raised to anything, you will get same. It is again constant. So here 2 will get cancelled here. 4 is at 12. That 17 raised to 3 by 2 minus 1. So inside the integration, you have d theta. Agree?
Yes, sir.
Integration of d theta.
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 If you put lower and upper limits,
2
2
pi.
pi.
2 pi
2
minus
pi.
0.
2 pi minus 0, 2 pi. 2 to cancel.
Yes, sir.
What will you get finally? Pi by 6. Pi by 6, right?
6.
Na? Not 16. Pi by 6. Huh?
Yes, sir.
17 raised to 3 by 2 minus 1. So let me check the option. Is there pi by 6? No, we had got.
C option.
Yes, sir.
Yes.
Option C.
Sorry. Yes. Okay, just a minute. Huh? C option. C is the correct option. No? Yes. Yes.
Sir, if you want to solve with dot polar form, then it may take more time or other problem get.
So there is one more way, no?
Yeah.
Norm. RU cross RV. In that way also you can find the surface area, right? You're talking in a, you're talking about the same, na? Using cross product also you can do it. Actually, this formula is derived from this one, okay? So if you use the basic one, then also it is okay. Otherwise, if you're comfortable with this one, that is also fine. But actually in your syllabus that this thing is not mentioned. I didn't see it anywhere. So that's why I use this one. Okay, so this is next problem. Just go to the question and tell me how to solve. They have given g of x, right? Which is, okay, I will multiply. So x square minus 2x. And this is 4x minus 5. F of t dt. And they have asked to find the derivative. F of x, what is f of x? They have that thing also mentioned here. F of x is root 1 plus 3x raised to 4. And we have to find the derivative. Can you see here? G dash of 1 with this thing we have to find. Any idea how to solve this problem?
Sir,
Any
can
idea?
we solve this by integrating like f of t with dt and just put the limits because x may be considered a constant, no? When we
No.
integrate function with respect to t.
But see,
Leibniz rule.
yeah, very good. See, I think you had the first one. I don't know your name, but see, you are talking about the direct method. That means solve the integration, then put the limits. But see, the Leibniz rule is quite simple. Okay, easily you can find. So let me write it first. What is it? Suppose g of x is equal to, you have this kind of thing, u of x to v of x, right? and you have some function f of t dt. And suppose you have to find the derivative g dash of x, then what you're supposed to do? See, when you take the derivative, that derivative and integration will get cancelled, and you can directly write f of v of x. That means I'm putting upper limit, okay, upper limit at a place of t, and then derivative of v minus, I will put the lower limit at a place of t. That means what will you get? F of u of x into derivative of u, that means u dash of x. Have you understood?
Yes, sir.
Okay.
Sir, it's
Now tell,
Leibniz rule, right?
yeah, Leibniz rule, yeah, right. Then tell me what will be the g dash of x here? If you use this formula here, g dash of x will be, this is my v, and this is,
4x minus 5.
f of 4x minus 5.
yeah, at a place of t, I will put the upper limit first. Just a minute, huh? So, okay. See, so f of 4x minus 5, but we supposed to take it derivative after it, right?
Huh.
4x
Into four.
minus 5. Now it's turn off lower limit. I will put lower limit at a place of t. What will you get?
F of x square minus 2x.
Yeah, right. And after that, we're supposed to take its derivative, right?
Huh.
Derivative of x square minus 2x. So let us simplify it further. So this is equal to f of 4x minus 5. What is this derivative? Derivative of this bracket, can anyone tell me?
4.
4.
4.
4, right.
4.
Minus f of x square minus 2x. And what is derivative of second bracket?
2x minus 2.
2.
2x minus 2.
But see, they have asked to find g dash of 1. Can you see in a question? They have asked to find g dash of 1. Now my task is to put simply x is equal to 1 everywhere. See what will happen if I put x is equal to 1 everywhere. Inside the bracket, you will have minus 1. Agree with me?
Yes, sir.
I'm putting x is equal to 1 everywhere. So if you put it here, it will be minus 1 simply into 4 minus. What about the next term? Inside the f, what will you get if you put x is equal to 1?
Minus 1.
It's 0?
Yes.
No, it's
0.
minus 1. It's minus 1. My mistake. It's minus 1. And what about the next bracket? I think it is, yeah, it is 0 now,
Minus 2.
right?
Yes.
So this is equal to 4 f of minus 1. 0 into anything, 0 you will get. But they have mentioned what is our f of x? F of x is, what have they mentioned?
Root 1 plus 3 raised 3x.
Root 1 plus 3x raised to 4. Root 1 plus 3x raised to 4. So let us put x is equal to minus 1 here. Let us see what we will get. 4 root 1 plus 3 minus 1 raised to 4 is 1. That means 4 root 4. That means 4 root 4 is 2. So it is 8. Is it clear?
Yes, sir.
Sir.
Okay. Shall we move further?
Yes, sir.
Okay. Very good. See, this is the next problem we have. So, a be a positive real number, right? F is a continuous function. So I'm reading what is the given thing. Function is a continuous, and most important thing, it is a even function. Getting f is an even function. You know, when we say the function is even and when we say odd, in previous 2 lectures, we have already covered this part, right? Even function we have on an interval minus a to a. Just a minute, huh? Yes, even function. And see, they have given an integral and they have asked what will be the value of that integral. Okay, so let me note down the integral first. I is equal to, the limits are minus a to a, f of x upon 1 plus e raised to x dx. Any guesses? How shall we start to solve this problem? Any guesses?
Since it's an even function, we must change the limits first.
Yeah, very good. See, we have already seen when you have an even function and when you have this kind of limits, we always write 0 to 0 to a f of x dx, right? When the function is even, and if the function is odd, we write 0. All
0.
of you agree with me?
Yes, sir.
Okay. I would like to use this thing, but I cannot use this fact because we are simply talking about the numerator. It is even, definitely it is even. But what about the denominator? Here the entire function must be even. The complete function must be even. Then only you can go for this even odd thing. Getting?
Yes, sir.
Here the
Yes, sir.
denominator. What do you think? It is even or it is odd? What do you think?
Even.
Exponential function. What do you think?
Even,
E raised to x is an even function.
even function.
What about others? All of you think the same?
No, sir.
Nor odd. Neither even nor odd.
Yeah, right. Neither
Odd.
even nor odd. When we say the function is even, f of minus x is equal to f of x, right? But when you have a function e raised to x, what happens here? See, f of minus x, if you write, you will get e raised to minus x. So that minus will appear in in power, getting now. So you'll never get f of x and you will never get minus f of x. So e raised to x is a function which is neither even nor odd. Getting my point? So
Yes, sir.
definitely I will not go for this properties of definite integral, right? Even odd function. I cannot use this thing. Then what is the second option I have? See, I'm asking you these things because we have already discussed such things in previous lectures. Okay. I think some of you told this formula also, integration a to b f of x dx, this property. You remember this property we had seen in last lecture? We had discussed.
Integral a to b f of
Yeah.
x, a plus b minus x dx.
A plus b minus x dx, right? Okay, this kind of thing we have already discussed in 12. Okay, in 12 examination, in syllabus, this part was there, right? Property of definite integral. So let us use this thing and tell me what will you get. So here a to b integration limits we have, but here minus a to a. Okay, so what will happen if I use this property? Minus a to a, f of upper limit plus lower limit, but the lower limit has a minus sign. That's why a minus x. Agree with me?
Yes,
Yes,
sir.
sir.
In denominator, what will happen? Tell me. 1 plus at a place of x, what we should write?
Minus
Alpha
x.
minus x.
A
A minus
minus
a
x.
minus x.
Minus, yeah, upper limit plus lower limit minus x. So this kind of thing we will have. So definitely a and minus a we can cancel here. Agree?
Yes, sir.
So you will get f of minus x. Understood? And in denominator, what will happen? In power also, this a and minus a will get cancelled.
E power minus.
Minus x.
Minus x. So see, minus x, right? But they have already told us the function is even. Function is even. So therefore we can write f of minus x is same as f of x. Agree?
Yes, sir.
Yes, sir. Yes, sir.
So minus a to a. So the function is even. So that's why I'm writing f of x upon 1 plus e raised to minus x dx. Okay. So is it same as I given I? Is it same as given I? Is it same as given I?
No, sir. They
No,
No,
sir.
e to the
in
power
the
minus x.
given
power
function it's e raised to
minus
x
is
and here
only
it is
the
e raised to
difference.
minus x.
Yes, it is not same as given I because let me write it here. Huh? In a given I, what we have? Minus a to a f of x upon 1 plus e raised to x we have. But unfortunately, we have e raised to minus x. So definitely it is not same as given I. But see, I need to solve it further. So what will I do? Integration minus a to a f of x. Okay, I will do my favorite thing. When you have any negative power, then what I do? 1 upon e raised to x. E raised to minus x is 1 upon e raised to x, right? Shall I cross multiply?
Yes.
Yes, sir.
Yes, sir.
What will I get if I cross multiply?
E power x into f of x divided by 1 e power x plus 1.
Agree. But that e raised to x is in denominator of denominator, we can shift to the numerator, right? So that means e raised to x, f of x upon e raised to x plus 1. All of you are agree with me?
Yes,
Yes.
sir.
Okay.
Yes, sir.
So this is value of I. This is value of I. We have original I. Okay, I have here also I have written. This is original I. And this is another I we have. So what will I do? I will add both I's. I plus I. Okay, both are actually same. The first one is a given value of I, that is minus a to a f of x 1 plus e raised to x dx. So this is given value of I. And now our calculated value of I is, you can see on the screen, minus a to a minus a to a e raised to x f of x upon 1 plus e raised to x or e raised to x plus 1. Both are same. Any guesses what I need to do after this? How can we simplify it further?
So by adding 1 plus e raised to x will be cancelled. So we'll get f of x dx.
Exactly.
Yes,
Very good. Very
minus
good.
a to
Very good. Very good. What's your good name?
Kashvi.
Kashvi. Okay,
Kashvi.
yeah. She said that, see, integration. Okay, whatever you said, now I will explain it one step by step. See, integration is same. So that's why I'm taking integration common minus a to a, right? Both of them have the same denominator. So we can write a common denominator 1 plus e raised to x, right? Simply, we need to add the numerator. So f of x plus e raised to x, f of x. So we can take f of x common. Agree with me?
Yes, sir.
We can take f of x common plus 1 plus e raised to x, f of x common. 1 plus e raised to. Can we cancel anything now?
1 plus e power x.
Yeah. Because we was saying the same. So that's why we got it. So I plus I 2i, right? I plus I 2i. And this minus a to a f of x dx. Now the function is only f of x. So definitely we can use its even odd property, right? So function is even. So what I supposed to write?
2
Function is
times
2 into
2
e
times
to the
minus
2
a.
to a.
Shall I cancel out this 2 from both sides?
Yes.
Yes.
So
Yes.
I
Yes,
will
sir.
be
Integral 0 to a f of x
Yeah.
dx.
That's it. Very good. Very good. Okay, let me check the correct option. Huh? Which one is the
Option
correct?
Option
A,
A.
na? A is the correct option. You're right. Okay, let's move further. Okay. So this is the next problem for us, right? Just a minute. Let me have a water. Okay. So two functions we have, f and g. Can you see on the screen? F of x, y, z is g of x square plus y square minus 2z square. It's quite
Yes.
simple actually. Okay. So we have to find a value of this. You can see here sum of this second order partial derivatives. Okay. So what we need to do, we need to calculate all these things one by one, and then we will find a sum of all, right? All of you are ready?
Yes, sir.
Let me copy the thing what we have. Okay, it is quite easy problem. If you are if you know the all formulas of derivative, you can easily calculate, right? G of, let me write g of x square plus y square minus 2z square, right? Okay. So let us find the first partial derivative by x. Tell me its derivative. Derivative of g is g dash. Agree?
Yes, sir.
I'm using chain rule. All of you are comfortable with chain rule, na?
Yes, sir.
Yes, sir.
Yeah, I'm taking the derivative of outer function first, which is g dash, and after that derivative of function inside this bracket. What will be its derivative with respect to x?
2x.
2x.
2x, right? So using chain rule, I got the by x. Now I will go for the second derivative. That means one more time I will differentiate with respect to x. But this time we have a two functions, right? That means I
So
should
we
go
have
for
to use
into v
product
form.
rule.
Product rule. Yeah. Can anyone tell me if I apply the product rule, what will I get?
Yes.
Huh.
G double prime.
Yeah. What will I do? I will copy g dash first. Okay. It's simple, no? So that's why I'm doing it. I will copy as it is and I will find first derivative of 2x. What is derivative of 2x?
2.
That's it. Okay. Now use this rule and tell me what will be the next term, second term. 2x as it is. Agree?
Yes, sir.
G double
Yes.
prime.
Derivative of g double dash
X
x
plus
square
y
plus
square minus
y
2z
square minus 2z square. And again derivative of this bracket
2x.
with respect to x,
2x.
2x. That means the first term is same. In second term, 2x into 2x. You get
4x square into z double dash.
g double dash. I will call it as u, for simplicity. Right? Yes. But see, the function is symmetric for x and y. That means if you interchange x and y, the function remains same. So similarly, I can write similarly, deba square f upon deba y square. Will you directly guess the second order partial derivative with respect to y?
Yes,
It
sir.
will be
Yes,
2g dash
2
x
dash
square
x square
y plus y square minus 2z square
minus 2z square plus
plus
4y.
4x,
4y,
sorry,
no?
4y, z double dash of x
You-
square plus y square minus 2z square.
Yeah, that is, I have called it as u here. Okay, instead of writing all these things again and again, I called it as u, right? But the-
4y square
sir,
होगा.
y square.
Yes,
my mistake, my mistake. Here also 4x
And
square and
also
4x.
x.
Thank you so much. Huh? Yeah. Yeah, g double dash of u. But see, we cannot write directly for z now because we have some different term for z, minus 2z square. Okay. So I will find derivative of f with respect to z first. Tell me derivative of f with respect to z.
It
This
will
is my
be
f.
z dash u into minus 4z.
This is my f, right? Yeah, please.
g dash
Z dash u into minus 4z.
G dash of u, or I will write here x square plus y square minus 2z square into derivative of this bracket, which is
Minus 4z.
Minus
minus
4z.
4. Yeah, using chain rule, I got this one, but I am interested in second order partial derivative. What will be it?
Minus 4 into g dash of x square
Minus
plus
4 g dash of x square plus y square minus 2z square, right? In plus u into v formula minus 4z as it is. I'm using u into v formula, first into derivative of second plus second into derivative of first. I'm copying this minus 4z as it is. Now tell me its derivative.
g double dash
G double dash x square plus y square minus 2z square into derivative of this bracket is minus 4z. Agree?
Minus 4z.
Okay. So this is minus 4 g dash of u minus minus plus 16z square g double dash of u. Agree with me?
Yes, sir.
Yes, sir.
Now simply we need to add f double dash of, sorry, deba square f upon deba x square plus deba square f upon deba y square plus deba square f upon deba z square. Let me simply copy here. Yes. 2g dash of u plus 4x square g double dash of u. Second term, 2g dash of u plus 4y square g double dash of u. And the value of third term, minus 4g dash of u plus 16z square g double dash of u. Can I cancel anything here?
Yes.
Like 2g dash
2g dash
Yes,
of
sir.
u
2g dash
u
u plus
plus 2g dash u, 4g
2z.
dash of u, and this minus 4g dash of u. And what about remaining terms? Can I take anything common?
The 4
4g double dash
g
u.
double dash u
4 I can take common as well as g double dash of
g
u also
double
I
dash
can take
u.
common. So that means you will get x square plus y square plus 4z square. Okay. Okay, that is the final answer which we have got. So let us check the correct option. Okay, 4 x square plus y square plus 4z square g double dash of u.
Option
Option
B.
B, you are right. In first option, there is a minus sign, no? This is the correct option. Have you understood?
Yes, sir.
Shall we move further, all of you?
Yes, sir.
Yes, sir.
Okay, very good. Just a minute, something happened to it. Yes, we got the next one. So we have one function getting, and we have to find its saddle points. Saddle points. So that means which of the following is a saddle point? Saddle point at.
Saddle points.
You know saddle point, meaning of saddle point?
No,
sir.
sir.
Okay,
No.
so let me tell you. Sorry. Anyone wants to
Sir,
say anything?
when the function changes its sign like from maxima to minima and minima to maxima, then
Hmm.
we got a saddle point.
Yeah. So that, or in other way, you can say the
Our
stationary point.
discriminant is 0.
Sorry.
Discriminant is 0.
Yeah, right. You're right. Okay. See, just a minute, huh? So I will tell you the procedure first. So that means when you have any function, we have a function f of xy. Okay. So it represents the surface, right? So we have to find its maxima and minima. So what we do first, we find derivative of f with respect to x, derivative of f with respect to y. We equate them with 0 and we find the stationary points. So next task is to find whether the function has maxima or minima. For that, we find the double derivatives, second order partial derivatives, fxx, fxy, and fyy. Okay, so for simplicity, I will denote it by RST. RST. So there will be several cases. If RT minus S square is positive and R positive, then what we get? Tell me.
Minima.
Yes, RT minus S square positive, R positive, then we get minima, right? Then we get minima, right? RT minus S square positive, R negative, then what we get?
Maxima.
Maximum.
Maxima, right? RT minus S square less than 0. That means what we get?
Saddle
Say
point.
the maximum now minimum.
Yeah, maxima nor minima. Okay, so when you get third case, neither maxima nor minima, then the corresponding stationary point is called saddle point. Getting? So let me mention the point we declare saddle point. That means it's a stationary point, but neither we are getting maxima nor minima. And if RT minus S square is equal to 0, then we say
test fails.
yes, test fails. That means this test is not applicable here. You need to use any another method to solve the same problem. Getting? Okay. So in our list, we have many problems of maxima, minima. Okay. So I hope all of you understood. Okay. Have you understood this one?
Yes, sir.
Yes, sir. Yes, sir.
Okay. So see, that means simply you have to find partial derivatives, fx, fy, fxx, fxy, fyy. You have to find the stationary points and then you have to find whether we are getting maxima or minima. Okay. So what is the function we,
Can we say that what point of inflection states in function of one variable is same as saddle point in
Yeah,
like
you're
one
right.
variable?
Yeah. Someone I think said already, na?
Okay.
Okay. See, what is function? Fxy, that is x cube plus 2xy plus y cube. Okay, so let us find partial derivative fx. Tell me its derivative with respect to x.
3x
Three
square
x
plus 2y.
Plus 2y.
2x square plus 2x.
Okay. Fy. Just a minute, huh? Fy, derivative of f with respect to y.
3y square plus 2x.
Plus 3y.
Fxx.
6x
6x.
Fxy.
2.
Okay. Fyy.
6y.
Okay, so this is my R, this is my S, and this is my T. Agree?
Yes.
Okay, so we know that when we say the point is a saddle point, right? When we say it is a saddle point, if RT minus S square is negative, right? So see, I will check. Instead of finding stationary point first, I will solve it in a reverse way. Whatever the options we have, we will simply check it is saddle point or not. What is the first point? 0, 0, right? So what is the first point? 0, 0. So at 0, 0. 0, 0 means R x 0 and y 0. So what will be the value of R, S and T at 0, 0? Tell me.
0.
0.
0,
R and T will be 0.
2, 0.
0. Agree? If I put x is equal to 0 here, if I put y is equal to 0, you will get 0, 0. Understood?
Yes, sir.
Okay. See, RT minus S square, tell me then. RT minus S square. RT minus S square. What will be its value?
Minus
RT
-4.
Minus 4
minus
less
it's
than 0.
negative. Right? So you can declare it as a
Saddle point.
saddle point. Have you understood?
Yes.
Sir.
Yes, sir.
Okay. So what is the second point? At just a minute, there's some issue I have. Yeah. Minus 2 by 3, 2 by 3. Minus 2 by 3, 2 by 3. Then tell me the values of RST.
R is minus
6
4.
into minus 2 by
6 into minus 2 by 3. That means you will get minus 4.
4.
Yes.
S is fixed, which is 2. And T
Minus
4.
6, 2 by
Plus
3.
4.
4.
2 by 3, 4. So let us find RT minus S square. RT minus S square. It is
Minus
minus
16.
minus.
Minus 4.
Minus
Minus
20.
20.
Is it negative?
Less than.
Yes.
Yes. Sir.
That means this is
Yes.
also saddle point. That means first two options A and B both are correct, right? Have you understood?
Yes, sir.
Okay.
Yes,
So
sir.
can you check remaining 2 points so I can move further? Can you check remaining 2 points?
Yes, sir.
Yes, sir.
Yes,
Give it
sir.
as homework.
Yes, sir.
Yes, sir.
Yes, sir. Om Prakash, have you understood?
Yes, sir.
Okay, let us move further. Okay, this is the
Sir,
next
can you-
problem.
Sir,
Huh?
can you go back to that question? We need to take screenshots.
Okay,
because-
screenshot. You are right. You are right. Yeah.
Okay, sir.
See, this is the next problem. So function of two variables we have x square y upon x square plus y square, and when x y is not equal to 0. And simply we have to check whether the function is bounded or unbounded. Understood? Na? Have you understood the question?
Yes, sir.
Okay. So one function we have, simply we have to check it is bounded or not bounded. So what will I do? I will convert it into polar form so we can easily find, right? So let us convert this function f of xy. Let me copy it first. So f of xy is x square y upon x square plus y square. Okay, I will convert it into polar form. You know what we do in case of polar form? We put x is equal to r cos theta and y is equal to r sin theta. Let us put it here and tell me what will you get?
Function is unbounded.
Function is unbounded. Yes, you are right. You are right. Okay, so let me simplify it first. Sunil, what will I get if I put these values here?
R cos square
R-
theta sin theta.
R cos square theta, r sin theta, right? And in case of
Mhm.
denominator, what will happen? X square plus y square.
So we will get R square.
One.
R square.
Shall I write directly, since cos square theta plus sin square theta is always 1. So that's why. Shall I cancel r square from numerator denominator?
Yes.
Yes.
R cos square theta sin theta. So in this way, we express the given function in terms of r and theta. But see, if r tends to infinity, r means what? Distance from the origin. Getting distance from the origin, if you move away from the origin, this r will go to infinity. And if this go to infinity, function will also go to the infinity. We are getting the point. So the function is unbounded.
Yes.
So therefore, some of you already said some f is unbounded. Getting function is unbounded, right? Function is unbounded. Okay. So they have asked to check partial derivative also. We have to find the partial derivative and we have to predict about its boundedness. So let us find its partial derivative, dy by x. So we have to find its derivative, right? Let us find the derivative first. So we have to apply u upon v formula to find the derivative. Khushi, will you help me to find the derivative? Khushi?
U by V is equal to the
You are not properly audible. Huh? U upon V formula, right?
yes, sir.
X square.
Derivative of U into B
Yes. Derivative of numerator minus numerator.
into derivative of denominator
Yeah, right. X square plus y
divided by square of denominator.
square of denominator. X square plus y square whole square. Okay, so let us simplify it further. Sifana, please help me. X square plus
Yes,
y
sir.
square.
Into 2xy
2xy. Very good.
minus x square y
Y into.
into 2x.
Yeah, very good. Divided by x square plus y square whole square. Okay, let us multiply 2x cube y. Agree? Plus 2xy cube minus 2x cube y. Can we cancel anything here?
2x cube
2x
y.
cube y
2x cube y.
Exactly. So what is remaining? 2xy cube
y.
divided by x square plus y square whole square. Agree?
Yes, sir.
Okay, I will follow the same technique. Here also we have to check boundedness. So I will convert it into polar form. That means x is equal to r cos theta and y is equal to.
R
R
sin
sin
theta.
theta.
Yes. Put it here. 2 r cos theta r cube cos cube theta divided by r raised to 4. Shall I write directly? X square plus y square is r square and square of r square is r raised to 4.
Yes, sir.
Set numerator
Sin cube theta. Sin cube theta.
here. Yes, my mistake. Here should be sin cube theta. You are right. Okay, so r raised to 4, this r and this r cube r raised to 4 and this r raised to 4 will get cancelled. So what is remaining thing? 2
cos
cos
theta.
theta.
Cos theta, sin cube theta.
Okay, so do you know this fact? Mod sin
Yes, it
theta
is
is always
bounded.
less than or equal to 1.
Yes, sir.
Mod cos theta is always less than or equal to 1. So that's why definitely it is bounded. Okay, so that means what we
Yes.
got? F is unbounded, but by x is
Bounded.
This
Bounded.
is our conclusion. The function is unbounded, but its partial derivative with respect to x is bounded. So tell me the correct option.
Option B.
B.
Option B.
Option B is correct.
Okay, so let us move on. Saddle point. Okay, so this problem also I will simply start and you have to finish, right? You remember now what we supposed to do? I will simply
Yes,
start this one, huh?
Yes.
What we need to do? We have to find partial derivatives, right?
Yes,
Yes.
sir.
Okay, let me copy. Okay, shall I directly write the derivative divided by fx? I will write fx. Tell me fast, what is fx?
6xy
6xy.
minus 6x
6x.
6xy
6x y
minus
minus 6x
minus 6x
fy 3x square, right?
12y square
12y square.
minus 24y.
y.
Yeah, right. Okay, so let us talk about RST. R. That means fxx. So tell me its derivative with respect to x. Derivative of fx with respect to x.
Y minus 6.
Y minus 6
It's y minus
minus
6y minus
s. fxy. Okay, derivative of f with respect to derivative of fx. इसका derivative निकालना है with respect to y. What will you get here?
6x 6x
That's it. T. fyy. Okay, derivative of fy with respect to y. Again, इसका derivative निकालना है with respect to y.
24y minus 24.
24.
Yeah, right. Okay, so it may have many saddle points. Okay, so let us talk about at 0, 0. What will happen at 0, 0? At 0, 0. What will happen at 0, 0? R is equal to what? 0, 0 means what? X की वैल्यू 0 और Y की वैल्यू 0. तो क्या आएगा? R की वैल्यू क्या आएगी? देखो
Minus
minus
6.
6
minus 6.
minus 6.
Minus 6.
S 0.
0
T minus 24. So RT minus S square. So that means minus 6 minus 24 minus 0. So minus minus plus, right?
Yes.
So 6 into
Greater.
24, that means
Greater
definitely
than equal
positive.
to 0.
So is it a saddle point?
No, so it is a point of maximum.
Point of
a
exact.
minimum.
R is negative and RT minus S square is positive. So it's a point of maxima. Exactly. Okay, but we are interested in saddle point. So that means the first option is not a correct option. Will you try for the remaining options?
Yes,
Yes,
sir.
sir.
Okay,
Yes,
just take a screenshot of it. Have you taken screenshot?
Yes, sir.
Yes, sir.
Okay, so actually many problems we have, but see, I will talk about the one doubt someone had in last lecture. Okay, so kind of this thing. Okay, so I will complete that doubt. So I had promised to come with one example, right? You remember, na, what was the problem we had in last lecture? So you were talking about area cannot be negative, right? The function integration always gives the area under the curve. You remember that fact?
Yes, sir.
Yes, sir.
Okay. So I'm taking a function here, integration 0 to pi cos x dx. Agree? All of you are familiar with the graph of cos, na?
Yes,
Yes,
sir.
sir.
Cos looks like this, right? Okay. So here we have pi by 2. Here we have pi. So we have taken limits 0 to pi. 0 to pi. That means this is the graph of cos. So we have to find, we are expecting this area we will get, okay, by solving this integration. So let us solve this integration. What will you get? Integration of cos is
Minus
sin
sin.
Minus sin.
plus sin x. Okay, I will put upper and lower limits. Sin pi minus sin 0. What is value of sin pi?
0
0.
Sin 0, 0. That means we are getting area 0, but we are getting the area some here, no, in a diagram. Why we are getting answer 0? Because here we get a positive area, here we get a negative. Actually, the area is not negative. I agree with you. But see, it is below the x-axis. So that's why it has a minus sign. So they will get cancelled to each other. And that's why we are getting answer 0. Getting my point?
Yes, sir.
Okay. If you want to check, you can do one thing. What we had taken 0 to pi cos x dx. What will I do this time? I will split this integration by using
0
property
to
of
pi
definite
by 2.
integral. 0 to pi by 2 plus pi by 2.
2 plus 5.
Getting? So cos x again, and here also cos x. So if you solve it, you will have a value here 1, and here you will have value minus 1. Okay, so area is 1 here, here area is minus 1. So they are having opposite sign. So that's why we are getting answer 0. Is it clear to you?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay.
Sir,
Okay.
so
Huh.
you mean the area will be not negative, but the integral value can be 0 or anything
Yes,
else,
yes,
right?
yes. So that's why when we solve few problems and when you get at the end minus sign and we are calculating area, we say the area cannot be negative and we rectify it, right now?
Yes, sir.
Okay. Okay. So the see one doubt was there. I do not remember right now. I had taken a photo of it. Okay. In next lecture, definitely I will show you. And if I am able to explain in next lecture, then definitely I will share its solution with you. Okay, I will try to finish it in next lecture. And one more thing, yes, some of you were asking for the surface integral, right? No, some of you are asking for triple integration in spherical coordinates, right? Now, some of you had written in chat box in last lecture. So in next lecture, I will discuss few problems of triple integration also with spherical coordinate system. Okay, 2 or 3 problems we will discuss in next lecture. Any doubt you have here?
No,
No,
sir.
sir.
No, sir.
Sure.
Hello.
Huh?
Can you show me the 8 is the problem?
Sorry.
8 is the problem today. We solve them.
Which problem?
18.
18. Problem number 18. Just a minute, huh?
Saddle point.
This one.
Yeah, this one. In this problem, the point should be satisfy the first derivative also, right?
Sorry, you are not
Because
properly audible. Please speak loudly.
the points, the
Points.
those they have to satisfy the first derivatives also, right?
They're supposed to satisfy.
The first
Yeah.
derivative fx and fy, they have
Yeah,
to
yeah, yeah.
zero.
Yeah.
But the b option is not giving me 0, like -2/3 and 2/3. If I substitute as in the fx and fy,
Huh.
they are not giving 0.
Yeah. You're right. Yeah.
Only 0 and 0,
0, 0, it satisfies. Very good, very good. Okay. So actually I forgot to tell you that. See, in this method, I explained this fact. So see, when what we do, we find stationary point first, right? Stationary point. This is also stationary point. When you solve these equations, you will get a stationary point. If you have the stationary point, then we can talk about these conditions. Getting? Then we can talk about these conditions. Basically, it should be a stationary point. Agree? What's your good name?
Ramesh.
Ramesh. Okay. So Ramesh told that the first point satisfies the condition of stationary point. That means when you put x00, its value should be 0. It is satisfying. That means you can talk about the saddle point. But in case of second point, where is it? Just a minute. Huh? Let me check. Some issue it has. Huh? OneNote is not. Yes. Yes. Yeah. So this -2, -2/3 and 2/3, it does not satisfy the condition of this fx is equal to fy is equal to 0. So it won't be a saddle point. Getting? So it won't be a saddle point. It is satisfying the rt minus s square is less than 0, but that dA by f by dA by x and dA by dA by y, both of them must be 0. But these conditions are not satisfying, so you cannot say it a saddle point. So, okay, I need to rectify this one, so it's not a saddle point. So in case of remaining points also, you need to do the same. You have to check whether they satisfy the condition of stationary points or not, as well as the condition of saddle point also. Thank you.
Sir, can you explain why that second point is not a saddle point?
Yes. See, when we talk about the saddle point, neither minima nor maxima, okay? Basically, it should be a stationary point. Getting the point?
Yes.
Yeah. And when we say it is stationary point, when your fx is 0 and fy is 0.
Okay.
Basically, it should be a stationary point. Then we classify. It is maxima, or it is minima, or it is a saddle point.
Saddle.
Okay. But the second point doesn't satisfy this condition. So that's why it's not a saddle point.
Okay.
Okay.
Thank you, sir.
Most welcome. Huh?
Why we use saddle point? Means why? Why should it introduce?
Introduce, that means, see, stationary point. See, stationary point means where the point. Just a minute, huh? Okay. See, stationary point where the derivative will be 0. Okay, I'm talking about the function from R to R, right? So here we are getting maxima. Here we are getting minima. But at some points you will have neither minima nor maxima. Then we call it as a saddle point. That means it is a basically stationary point, but neither minima nor maxima. Understood?
But so it is only just pure mathematics, or it is applied somewhere in real life?
Yeah, it is applicable actually.
So where?
Calculus paper is totally applicable, getting no? In engineering, in physics, majority. Mechanics is also one of our branch, no, of mathematics. There also all these things are used.
Okay, sir.
Hmm.
Sir, what is the geometrical meaning of double partial derivative?
Geometrical meaning. See,
How
rate
can
of
you?
that means you wish to visualize those things, na?
Yes, sir.
Yeah, but see, after certain point, you cannot visualize this thing. See, partial derivative means what? Rate of change in a particular direction, right?
Yes, sir.
Okay, so that means when you have function like this, getting? So it is changing in both direction, x-axis and
Y-axis.
y-axis. Getting the point? Suppose we have a function like this. So with respect to x, there is no any change. It is a constant. But with respect to y, there are changes. We are getting the point?
Yes, sir.
Okay. In direction of positive x-axis, there are changes. We call it as partial derivative of f with respect to x. And positive in the direction of positive axis, we say partial derivative of f with respect to y. And if you are choosing any random direction, then we call it as a directional derivative. So this is the simple meaning of partial derivative. Getting? And when you talk about second order partial derivative, in that case, what we do? When you take a partial derivative, getting, for example, suppose you have f of xy is equal to x square plus y square. Okay, what will be its derivative? Tell me, by x, 2x.
2x. Yes, sir.
It is again a function. It is again a function. Again, you can plot its graph. That means again there will be the changes. So that will be the second order partial derivative. Understood now?
Yes, sir. Then we apply same as in 2x is apply same
Yeah.
as first one.
Yes, you're right. Okay.
Okay, sir.
Yeah,
Thank
you
you, sir.
have one more lecture, right?
Huh?
You have one more lecture, right?
Yes, day after tomorrow. See,
Sir,
I plan to cover, just a minute, huh? Let me show some. So some of you told me that spherical coordinate system also I supposed to cover maxima, minima, again some problems there, critical points, and see iterated limits and partial derivatives. All these things I have planned to cover in next lecture, and some problems of spherical coordinate system. That's all.
sir, can you also cover surface area and volume of solid of revolution?
See, I have just one more lecture. No, I don't think. See, on an average, I can cover just 6 to 7 problems in a single lecture, right?
Yes, sir.
So, if you have any doubt or any thing you want, you can communicate with the madam from the Winsell College. Getting? If you
Okay,
have
sir.
any doubt, you can send to me. I will give the solutions or the proper notes on that.
So you mean I can send my doubts in the Telegram channel, right?
Yeah. You can communicate to the madam, or she will give my email ID to you, right?
Okay.
Sir, can I ask a question?
Please.
Sir, how can I improve on calculus?
Calculus, that means what is the exact difficulty you have? You do not remember the formulas of derivative integration, or you do
Yes,
not
yes.
visualize those things.
Can
What
you
is
give me this lecture of this like this calculus series?
Okay, so you want few more lectures on this topic?
Yes, calculus.
See, I have already uploaded many lectures on my YouTube channel. Getting? If you want, you can give the suggestions there, which topic you want to cover. Getting? So I will try to cover the maximum topics.
Yes. Sir, what's your YouTube channel name?
Ranjan Khatu, RAN
Ranjan.
Khatu, RANJN KHATU, Ranjan Khatu. Many topics I have already covered there.
Thank you.
Most welcome. Okay, so shall we stop here then?
Yes, sir. If there are no doubts, I think we can stop. So thank you so much, sir. So we look forward to
Thank you,
your
ma'am.
one more session.
Yeah,
Thank
sure.
you, participants. So we'll meet for the next lecture. Thank you so much.
Thank you so much, sir. Thank you so much,
Thank you
ma'am.
so much.
Thank you,
Thank
ma'am.
you, sir.
Most
Thank you,
welcome.
sir.
Most welcome.
Thank you,
Thank you.
ma'am. Thank you, sir.
Thank you, sir. Thank you, ma'am.